current transformers. I am going to discuss and talk about current transformers and how they work. Theory of the current transformer. When the current passes through the primary coil, a magnetic field is generated in the iron heart and produces an electromagnetic force that determines the current value on the secondary coil, where it converts the current passing through the primary end to a current proportional to it on the secondary end. If you look at this picture, you will see the construction of a CT. It consists of three main parts. The primary winding is a conductor and iron core. The secondary winding from the iron core, which are wires wrapped around the iron core. For example, in a current transformer which has a conversion rate of 100 to 1 current, a current of 100 ampere is passed in the primary coil, and the current on the secondary coil is 1 ampere. Also, when the 80 ampere current passes through the primary coil of a 100 to 5 CT, the current value on the secondary coil is become 4 ampere. Note, the secondary circuit of the current transformer shouldn't be opened because it increases the magnetic flux at the transformer's iron heart. As a result, its temperature increases and causes breakdown for the insulation of the coil, and the voltage will also increase more. When you look at this picture, you will see three cases of a CT with three loads. The first one, the CT is shorted here. This is 0 voltage and called zero burden. The second state, when you connect a load with a half resistance with the CT, this is a small value, so it's called typical burden. And you will connect a very big resistance or load with a CT, it's called high burden. Types of current transformers. There are two types of current transformers: outdoor current transformers and indoor current transformers. When you look at this picture, you will see outdoor current transformers with variable kilovoltages, from high voltages to medium voltages. This is the input terminal and this is the output terminal of the CT. And it's used in high voltage and installed outdoors in air, and is widely used in distribution substations. This type is internal inside the cell or distribution boards and takes different shapes suitable for the place of insulation and ways to connect the interior, where there is a circular current transformer in the shape of a bar, rectangular and cylindrical shape. When you look at this picture, you will see three types of shape of current transformers, which is placed indoor: circular, rectangular, and cylindrical. Let's ask a very important question and try to guess. What are the specifications of current transformers? First one, operating voltage. Second one, classification of the grid in terms of a measuring transformer or a protective transformer. Conversion rate of the current transformer. So, next question, what is the purpose of grounding the current transformer? I think it's very important question. Here in this picture you can see three CTs which are connected into the ground. The objective of any grounding operation is to protect against excess current or short circuit currents, whereby grounding the current is leaked to the ground due to breakdown in insulation, where one of the ends of the secondary of current transformers must be connected in star connection to the ground due to protect the measuring and protection when breaking down the insulation of the transformer, and also avoid passing the high voltage from the primary to the secondary side. Conversion rate in current transformer. It represents the ratio between the number of coils of the secondary to the number of coils of the primary, and also equal the ratio between the value of the primary current to the value of the secondary current. This is the formal equation of current transformer. If we talk about the power of current transformer, it is the power withdrawn from the connected load of the secondary coil and expressed in volt ampere as the rated secondary current and equal 5, 10, 15, 30, 60 volts ampere, calculated from the following relationship. Volt ampere represents the consumed apparent power. K equals 0.44 in the case of secondary coil current of 5 ampere. K a factor equals to 0.0176 in the case of secondary coil current of 1 ampere. S the area of the cable. L length of the cable. Now let's do some important calculations of current transformers. First case on the cables. Practical example. A cable works on a 33 kilo voltage operating and carry a power of a 25 megavolt ampere. What's the current transformers required for this cable? To calculate the highest current value in the cable, we write the main power equation. And the calculation is 438 ampere. So a current transformer of 500 to 5 is selected and the conversion ratio is 100. The secondary current is, in the case of normal load, equals this value 438 to 100 and equals to 4.38 amperes. But in the case of two cables with a total capacity of a 25 megavolt ampere, the current transformer value is calculating according to the total capacity. If one of these cables fails, the current transformer is installed at a value of 500 to 5 on each cable. Let's see calculation of current transformers on the power transformers. Practical example. What's the value of the current transformer on the high voltage side of a transformer with a capacity of a 25 megavolt ampere, which has operating voltage of a 33 kilovoltage? To calculate the value of full load current on high voltage side, you have to write the power equation. After calculation, the value of ampere is 438. So the current transformer which is needed here is 500 to 5. And the conversion ratio is 100. And the secondary current is, in the case of normal load, equal to 4.38 ampere. To calculate the value of full load current on the low voltage side, the result will be 1312 ampere. So here we need 1500 to 5 current transformer, and the conversion ratio is 300. The secondary current is, in the case of normal load, equal to 4.37 amperes.